And good morning. All right, we're going to go ahead and start lesson 17.2. And in your book with the worksheets, you're going to have two worksheets over this. There's one 17.2A and then 17.2B. You're only going to have just this video, but you don't have to do both worksheets today. You can do one today and then one tomorrow if you want to. So anyway, let us go ahead and begin. We're on page 336. So if you'll go ahead and turn to that. Actually, if you're on the accelerated daily schedule, the assignment sheet does say that you'll do 17.2A and B today. If you're not on the accelerated schedule, if you're just on the regular schedule and you usually just do one worksheet a day, then you can just do one a day. But if you usually do more than that, then you'll want to do both today. Okay, so let's look at 17.2. Now, we can use what we know about the areas of parallelograms and triangles to help us find the area of lots of other shapes. For instance, take a look at the shapes below. So there you have a regular polygon. It's a hexagon, meaning it has 6 sides. And there you have an irregular polygon, meaning all the sides are a little bit different. So finding the area of these polygons looks impossible at first glance. However, notice what we could think of both the regular polygon, the hexagon, and the irregular polygon shown as a number of different polygons for which we do know how to find the area. In other words, so look right there in the middle of page 336. So they've shown you how that regular polygon, you can break that up. You'd have to use like a ruler and a light pencil, and you could kind of break that up. I mean, you could see, of course, you wouldn't have to do that if you were doing your, actual assignment. They're just doing it to show you what you do. So you can see how that regular polygon is broken up then into 6 triangles, 6 perfect triangles. And then that other irregular polygon, notice how they broke up one section into, actually they've got a big triangle, they've got a small triangle. My cat's in here beside me. They've got a big rectangle, and then they have a smaller rectangle. See how they just kind of, those dotted lines represent lines where they wrote those in, trying to just break those up. Now you can easily find the area by finding the area of the individual parallelograms and triangles, and then add all of them up. So we're going to try. So first, the first example is we're going to find the area of that regular polygon, the hexagon. So they've divided it up, and then they were given the measurements. So the base of one triangle is 3 feet. The base of the other is 4. So actually 1, 2, 3, 4, 5. Yeah, that's 6. So it has 6 sides. It could be thought of as 6 triangles. We know the triangles are all the same because we were told the hexagon is regular. Remember, to be regular, a hexagon's sides must be the same. Its angles have to be the same, which would result in the triangles being congruent. Does all that make sense? All right, so all we need to do then is to find the area of one of the triangles and then just multiply it by 6. And that will be the total area. So the area of the triangle, remember they wrote their formula first, half times base times height. And then they plugged in the numbers, half times 3 times 4, which is 6, because 3 times 4 is 12, and half of that is 6, so it's 6 square feet. Now, so one of the triangles, the area is 6 square feet, but there are 6 triangles in that hexagon, meaning that you have to take 1 and multiply by 6. So actually, the entire area of that hexagon is 36 square feet. Make sense? All right, we're just adding one little step to what we've been doing. All right, now let's find the area of this irregular polygon. This is the one where they kind of had to draw it up a little different. Now the irregular polygon shown can be thought of as 2 different parallelograms and 2 different triangles. We need to find the area of each, then add them together. Now, the area of the large parallelogram, you see it's 5 by 3. They just multiply length times width. They get 15 square feet. All right, now that small parallelogram, you see down there in the corner, it measures 1.5 by 2 feet. So multiply that together and they get 3 square feet. The area of the large triangle is half times 2 times 2, which is 2 square feet. The small triangle is half times 1.3 times 1, which gives you 0.65 square feet. So you've divided this up. You've gotten the area of each one of the separate little sections that you divided up. Then the total area at the bottom, you just add all of the areas up. And it comes up to 20.65 square feet. All right, let's look at the gray box where it says area of regular polygons. The same strategy we followed for the regular hexagon works for any regular polygon. To find the area of a regular polygon, multiply the area of the individual triangles formed by the number of those triangles found in the regular polygon. An octagon will have 8 triangles. A nonagon will have 9 triangles. A decagon will have 10, etc. So it gives you some examples right there. If you have those, just figure the area of one of those and then multiply by how many triangles is made up of that. All right, look at the next page. There's an important gray box here. Since irregular polygons are irregular, the exact shapes we'll need to use to find the area of each one will vary. The principle is simply that when we don't know how to find the area of a shape, we think of it as several shapes for which we do know how to find the area. So you can take an irregular shape, for instance, the one over here at the very top of 337, and most likely you would have divided it up like that. You say, well, that's an odd shape. How am I going to figure that out? It would be like if you were looking down on a drawing of your home and you were trying to figure the area of a couple of rooms, maybe a closet, a bathroom, and a bedroom that you wanted to put new flooring down. You're like, well, this is oddly shaped. Well, you would measure it and then draw it out, and then you'd have to, draw, imaginary lines so that you could say, okay, well, this is a triangle, so let me figure this, and then you just add them all up. So it's really easy. Now, the keeping perspective asks a very important question. When will I use this? Well, just as some kitchen gadgets, spoons, forks, etc., are used all the time, while others, like the turkey slicer, etc., you might only see and use now and then. You'll find yourself using some math concepts frequently and others only now and then. Unless you go into an occupation that requires finding areas regularly, it'll probably be one of those now and then concepts for you. But that doesn't mean it's not important. Besides knowing how to find an area when needed, you're learning problem-solving skills that will help you in other areas of math and life as well. Now, let me give you a little example here right quick. Many years ago, we lived in a little house in Commerce. In one of the back rooms, it was a little tiny room. Actually, when the house was built in the 60s, this little tiny room on the blueprint, because I actually had the original blueprint, it showed that this little room was a sewing room because the lady that had the house built was a seamstress. Okay, so it was a very tiny room and it had a very tiny closet. So I'm assuming they put the closet there just in case they wanted to use it as a bedroom or something. But anyway, so it was very small. But this is the way it looked. Now, there was a door right here, and there was a window right here. But it was a very, very tiny room. So when I became pregnant with Zadok, I decided that this little tiny room was going to be his nursery. Now, he was baby number 10, and I had never had a nursery before because I had so many children so close together. We just never had the time or the money or the space to have a nursery. So now I had 2 of my children moved out, so I was having a new baby, so I had this little extra room here, and I thought, well, I'm going to use this as a nursery. But it needed to be redone. It needed to have, the carpet needed to come out, and I wanted new flooring in there. I wanted it to be painted. So this, what we're learning today, came in very handy. So I went in with a tape measure and I said, okay, now it was a little easier than the shape that we looked at on the page because they were both just perfect little squares. So, but what I had to do was I had to find the area of this room. So I measured this wall, and I multiplied it, and that told me the area, the square. I think I measured it in feet. So that told me the square footage of this room. I had to do the same thing for the closet. I measured this way, and then I multiplied by square feet to get the square footage of the closet. And then I added the two together. And then we went to the store and we were able to buy the right amount of flooring for the room. So that's just an example of when you will use this. Okay, so let's go ahead and look at our worksheet. This is 17.2A. Now it is front and back, and you can use your calculator on sections 1 and nope, you can only use it on section 3. So let's look at number 1 where it says finding the perimeter. Now this is a little different. Remember perimeter. Perimeter is the outside. It measures the outside around its shape. So to find the perimeter of each of the following shapes, keep in mind that these shapes could represent the boundaries of property or bridges, road signs, etc. Remember, when finding the perimeter of a figure, you use all you know about the figure to help you find the missing sides. For example, you know a rectangle has 2 pairs of equal length sides, so only one of the pairs will be labeled. So they have, let's see if we can do this. They have this rectangle, and then they have, trying to draw it like it's, yeah, this isn't going to be exactly what they show. Yeah, this isn't going to work, but anyway, you get the idea. I'm trying to make it like they have it on here, but this is just this is not the same triangle that they have on the. In fact, this is an equilateral, meaning it does not have a 90-degree angle anywhere. So probably it'd be better if I just used straight lines. Well, if it's ever going to let me use it. So let's see, you're going to come off of here, and then you're going to use another straight line. Yeah, so this one's going to have to be a little longer. Oh my dear. There we go. So, okay, pretend like that's not there. Okay, I've drawn this. Okay, so this is the first thing that we have on A here. So this is a parallelogram with opposite sides equal, and figure C, the one I don't have drawn, is a regular hexagon. They're just letting you know. All right, so that's figure 1B and 1C. So this is figure A. So this is telling us this is 12, this is 6, this is 12, and this is 6. And then this is 8, and this is 10. So, but remember, it wants perimeter. Perimeter, you add all the sides up. So, if you'll notice, this is 12, and then this is 8. So that means this whole side here would be 20. Okay, plus, all right, so this is 12 plus this is 6 plus this is 10, and I do believe that's it. Now, it shows us in the picture that this right here actually is dotted, and it says it's 6. Do we need to include this in the perimeter? We do not, because remember, perimeter is just the outside measurement around it. So then you would add this up. Now, the unit that it's measured in is feet. Do you square? Would this be square feet? it would not be, because it's not being measured with little squares. You're just measuring in feet all the way around it. So when you're doing perimeter, it's just feet. Okay? Now, now you're going to do the same thing on 1B and 1C. You're just finding the perimeter, just the outside measurements. Now look at part 2. It says finding the area. You're going to go back and you're going to find the area of each one of those. Now remember, C is a regular hexagon. Hexagon is 6. So it has 6 sides. So therefore, if you'll count, that would be 6 triangles. So you'll need to find the area of one triangle and then multiply that by 6, and that would be your answer on C. Now on 1B, to find the area, remember we're finding the inside. And then on 1A, you've got 2 different things there that you're going to find. Now on 1B, that is just a parallelogram. That's all it is. So to find the area of a parallelogram, remember, it's base times height. Remember, you need to write your formulas too, okay? So for a regular, to find a regular parallelogram area, it's just this formula. Plug in your numbers and then get your answer. But on 1A, you're going to have 2 formulas. You're going to have the area, the formula for the area of a triangle, and then you're going to have the formula for the area of a parallelogram. Then you're going to add all of those together. Okay? Now look at the back of the page. You've got surveying here on 3. You can use your calculator. Just use what you know. I'm not going to walk you through it. Just kind of want to see how you do on that. And of course, then the skill sharpening. You're going to be doing some converting. Look back in your book if you need to on that one. Now, I'm going to go ahead and just kind of look over 17.2B right quick. So on, let's see, you got some figures at the top. So on number 1, number 2, and number 3, you're going to be able to use your calculator. You're going to be finding perimeter, area, and then averaging the area. Okay? Remember, perimeter is just adding up the outside. You don't have to do anything for the inside. And it's not squared. But area is all the insides added up, and it's squared. Okay, don't forget that. All right, if you would look at page 256 then, on part 4, you're going to use your calculator on this too, working with hexagons and B's. You've got some easy stuff there. And page 257 should be pretty easy. So how about this? I'm not going to plan on grading 17.2A and B, but I'm going to make a note here that says if you got it and you understood it and you did well, I will take a grade. If you don't do well, that tells me that you didn't quite understand, so I won't take a grade on it. Okay, so like I said, if you do the accelerated schedule, you're going to do both of those today. If you are on the regular suggested schedule, I do believe you're just going to do one today and one tomorrow. Okay? All right, let me know if you need any help.